Welcome to Haxby Shed and my last video before Christmas 2022. It's part 5 in the series servicing this Harrison universal milling machine, which was new to me quite recently. And this video is mostly about the main motor. You'll see me breaking the pulley, trying to get it off, getting the bearings out, extending the motor shaft because it was too short, recutting the keyway, repairing the pulley, and refitting it, putting it back on the machine and doing some tests. So I hope you find it useful. Something a bit curious here with this motor pulley. You can see in there the glue. I would guess it's araldite, something like that. And actually this end of this motor shaft sits quite a long way down there, about 15.5 millimeters. I measured that. I think the pulley is original. I'm not so sure about the motor, we'll just have to see. I can see the araldite at the base of this pulley as well. Oh, what happened? Oh, I've just smashed my pulley. Oh, what a twit. Well, oh, that's a TIG welding job then. Do you know, I was just beginning to think about that. Oh, aluminium pulley. A lot of force. Snap. Darn it. Well, I've been thinking about this, how to improve the puller setup, and I can't think of anything, so I'm going to take the same risk again, but I'm going to heat up the pulley. It's pretty hot and I think it's moving. Yes, it's coming off now. It's just forced the araldite to give up. This thing is fighting me all the way off, you know. It's pretty tight again now. And I can't think for what reason they had to araldite it on. One shaft, one pulley. We shall see. Ow. This is a bit awkward as well, getting these spring clips up. Come on. Next issue, it looks like the fan just presses on. I'll bet that'll be awkward to get off. Metric, no. Imperial fraction, no. 2BA. Fight me on this one. Sure you will. Okay. How many fins shall I break off, do you think? 2 or 3 maybe? Oh, it's coming. What do you reckon? This end, bit noisy, that's all. This end, difficult to show you, but it's got a right wiggle on there. Well, it has moved down to about there, but I'm very worried about breaking this middle out. I can't do TIG plastic welding. It's going. Now, yes, it's going. Phew. Phew. That's pretty tight, that, you know. Oh, I bet you there's a spring clip or something. There it is. I couldn't see it in this light. Well, I think we can rescue it. It's binding a little bit where it had swelled the groove that clip was in. I did file it slightly. It'll be all right. There we are. There is definitely no clip on this end. but it's still tight, my goodness. Ooh. If this pulley comes off easily, I'll check the balance on it. This is a pegged washer. Peg. Well, was this easy? Just like that. Try and ignore the junk. Let's just test this. I've set the bubble to the centre here. Looks alright, doesn't it? And I found a roll of cardboard, a cardboard tube, which is the perfect size for this, to give me an approximation anyway. Oh, I don't know. There's nothing dramatic, is there? I don't think that needs any attention at all. I just want to check how far this motor shaft sticks out and how far the pulley should go onto it. Now, the distance between this flange here and the end here is 50 millimeters. I've just measured it. So when we look at it on the machine, I'm having to do this handheld. So when I check with a straight edge from the top pulley, it comes to this line here. And maybe down the bottom there, you can see that rule sticking out. Now, that rule has to stick out 65 millimeters from the mounting plate to line up with this. I mean, obviously I'm off at an angle, it doesn't look right for you, but trust me, it's 65 millimeters. 50 millimeters shaft stick out would be too short. And that's why they've put the pulley on the way they did. So whether that motor was swapped or something, I don't know, but the shaft is a bit too short. I'm going to extend this motor shaft by about 15 millimeters. I've ordered up a longer key. This key is 8mm by 7mm. This is 10mm by 1.5. Now, I've spent about an hour on this already and I haven't made a chip because I've been checking all the setups and making sure that I can actually do this and not start it, get halfway through and then go, oh dear. We'll try a bit of this mystery bright bar, but I think it's going to be too tough and too difficult to cut the keyway. Oops. Well, nothing broke. I think I was just running it too slowly. I'll do it by hand. You've just got to keep the speed up. Yeah, that really was speed sensitive. 750 RPM at the end. I was forever looking up the tapping drill sizes for metric threads until somebody commented, take the major diameter, less the pitch. So for 10, it's 8.5. Well, so far so good. Got to wait for this key to come round. Well, I forgot to purge the line at the beginning, but otherwise I think that went all right. You can see now why I centre drilled the end of this screw. Now it's not perfectly concentric, but it's good enough. I mean, mainly the pulley will be held with the key. What's the correct cutting speed for araldite? Gently does it. Well, I got there in the end. There was so much rubbish inside this pulley. You could see it had been chafed where it had probably been rattling on the shaft at one time. That's probably why they put the araldite into it. I couldn't get this end absolutely concentric with this, but this was running out anyway by a bit. I could have used the centre steady on it, but I don't think I could have forced it into running true anyway. So next job is to cut this keyway. It's taken me a while to get this set up in the shaper to cut this keyway here. I had to grind the tool to 8mm wide. I've clocked this armature here, rotor, whatever it's called, to be flat, horizontal, packed up with some wood. I've clocked the jaws to be 90 or in line with the action of the shaper. Now what I'm going to do this time, for the very first time, I'm going to use the table ratchet advance on the up and down movement, because I'm no good at working the handle on the backstroke, not for a very short stroke like this. And I can set it hopefully to move at 1/4 at a time per click, so 0.1 of a millimetre. So I need to swap this mechanism up. Now I made this piece here and it's got a built-in clutch. Now the clutch has never been tested, but what it does mean is, the design means, I can take this off as a unit and simply slip it on the bottom. And to move the table upwards and downwards, this has to hang below and the lever goes below. And I had to move this emergency stop. There was a switch box there before. I've put on this emergency stop, but because it doesn't go out so far, it gives the clearance from this oscillating lever. So it's quite easy. You just take this ring off here. Can you see this ring? This ring off here. This then pulls off. Now I think I can just drop this on the bottom. I've got to obviously get the key in, so the key's here. Okay, so I think I've got everything right. The advance is on the backstroke, and when it does advance, the table comes up. One click at a time. Well, here goes nothing. Whoa, that's a bit hard, isn't it? Don't like that much. Well, I've stopped that because the table's not rigid enough. I'm going to have to put the leg down on the table, which means I can't do the vertical advance, but, well, it was nice to try. Well, we'll have to do it by hand. You get the idea. I'll just keep working on it. Well, that bit of metal did make it a bit tough to cut that keyway, but with a bit of patience I got there in the end. Well, there we are. I think it lines up very nicely. I wish I'd spent just a little bit more time on this here, trying to get this perfectly aligned, but I'd spent 10 minutes on it or more. Pulley fits on all right. It's just my pride, really, that's all it is. It's time to try and do something with this motor gearbox cover. I think what's happened here is they've made a gasket for it which is too soft, tightened it up and then pulled the screws through, and they made a right mess of it, to be honest. And then they've tried to repair it. You can see they've machined a counterboard out here, put washers in it. What they thought that would do, I don't know. They've cracked it here, cracked it there, and then where they haven't pulled it through, they've caused it to swell, so it's kind of erupting here. And generally it's quite a mess. I would be nearly better to make a new one altogether, but I'm going to try and stick with this. Well, that's about 20 minutes work. I just took a big countersunk to those holes. I'm just opening them right up. I'll fill them in and remachine the whole thing. That's all four done. My policy was just keep going. Whatever happened, keep going, keep going, keep going. Some of them look, you know, quite reasonable. Others are a bit suboptimal, let's say. Now I'll find out later if we've got any cavities in here. Whilst I seem to have a bit of a rhythm going with TIG, let's get this pulley sorted. I've ground this away at the back here, but not just here. And I'm hoping that I've left enough on to locate it. I can always do a fillet at the back here if need be. I mean, it's only aluminium. It's not going to have a problem with balance, I don't think, at that size. I'll just tack this in a couple of places first, maybe here and here. Hopefully then get the clamp off and we'll be on our way. Well, that wasn't my best work, but the important thing is it's all lined up on this face here and it's not a blob. Well, the motor bearings have arrived. SKF, to keep Lennart happy, who comments frequently from Gothenburg, Sweden. 6203 ZZ and 6205 ZZ. Well, that feels a lot different, but you'd hope so, wouldn't you, after all that work? I know I said I wasn't going to machine this pulley, but actually I'm going to clean this up slightly, and also I've discovered that my bit of welding here, it's not perfectly in line. When I put the belt on it, this bit here where I've welded on is just a little bit this way, and I don't want to create a vibration as this pulley goes round, so I'm just going to clean up the inside of here and I'll cut the other pulley groove the same, so the belts are, you know, set in the same by the same amount on both sides. We're cutting in reverse here. Well, it's not a beauty contest, that'll do. I just wanted to take some of the big lumps off. I'm going to use this parting tool to shave this face. I've measured the angle. Now, nominally, it should be 20 degrees from straight across. It's actually 18. What's happened is, this bit I've welded on, it is canted a bit to the right, probably about as much as 1 millimetre at this edge here. So there's no question it has to be machined. I'll just take enough off, that's all though, because I don't want the belt to drop too far in. And what I'm doing is measuring using a dial test indicator on the saddle so that I can see how much I'm cutting away, and then I'll do the same at this side here. You can see how I've got the DTI set up, and it's set pretty much to 0. It's 0.6 of a mil actually, so not quite as much as I thought. So I'm trying to do this in one cut. Now if I can't cut the other side, I'm stuffed. Unless I can get belts of different thicknesses. You can see it just scrapes that top edge where I welded it. So 0.6 mil, that's the minimum I could take, that's fine. I'll just try the belt in. That'll be fine, there's no chance of the belt bottoming in there, look. You know, these Harrisons are very bespoke because the angle on this side isn't the same as the angle on this side. That was at 18, this is probably a little bit shallower. And also, measuring this gap here, across there, 13.3. Now, to make that one the same, I've got to take 0.8 of a millimetre off, not 0.6. You've got to watch out with this stuff. It's just not CNC made, is it? It's handmade. Well, they measure the same. Let's try the belt. That's just flush with the top. And that's just flush with the top. So that's good enough for Haxby Shed. This is the 8mm by 8mm key. Now I ordered a 7x8. The 7x8 hasn't come. I think we're in the midst of, you know, so many postal strikes at the moment, and things have become quite unreliable. Well, adding 15mm onto the shaft there means that the key is pretty much the full length of the pulley. And if this is right, if I push the pulley on and I measure off the front face, the distance between here and here should be 65. See if that's on camera. Yes, it is. 65, spot on. Good. So we'll put a bit of Loctite 641 on this screw at the end there. Excuse my voice, by the way, I've got another cold. This Loctite is one that you can get apart fairly easy for maintenance. I did think about putting in another grub screw here, but I thought, well, with this on the end and the big washer, I don't think it'd be necessary. So that motor can go back on now. I'll just mention this in passing. When I was about 16, our apprentice master always used to say you can tell UNC from Whitworth because UNC was marked with contiguous rings. So contiguous means touching at the edges. And just look, this nut here which holds the motor, one of the four, is marked with contiguous rings. Do they still do that? Okay, first with no belts. Well, turning it by hand it's quite enough. It runs at 2,800 RPM, so it's a 2-pole motor. Well, actually, it's quieter with the belts on, I think. Right, lower range, 234. High range, 1500. I've just put the belts cover on there and that's made it quite a bit quieter, and I think by the time that I've got all of the vent covers on in the base, I think the machine will be reasonably quiet. Well, I'm pleased with the way that turned out in the end, but it's a bit like the story of, for want of a nail, the ship was lost. I don't understand why people don't fix the root cause of these things. I'm sure they've got their reasons and it gave me something to do. Anyway, the next job is to sort out the lid for this table gearbox. But it won't be today because it's damn cold in here and I'm losing my voice. So I'm going to go and get something to eat. This is what happens when your machines are frozen and then a warm front comes in. I think we were about -2 Celsius in here, and in one day it jumped to 14 Celsius. So that's about, I don't know, more than 30 degrees Fahrenheit increase in one single day. Of course, everything then sweats and it all rusts. No matter how much you wipe it, you can't be there all the time.